Welcome to Part 5 of Competency 6. In this video, we will work with applications of quadratic equations. Number 1. A boat takes 2 hours longer to travel a distance of 40 miles when traveling upstream than it takes to travel downstream. If the rate of the current is 3 miles per hour, what is the rate of the boat in still water? Okay, before we go any further, we're going to call the question the rate in still water. Let's call this X. Now, let's go back to the first sentence. A boat takes 2 hours longer. So we're going to say 2 plus to travel a distance of 40 miles. Okay, now we're going to travel that distance, whatever the distance is, we're going to travel upstream, and that's going to take us some hours. So we are actually saying that it takes 2 plus the hours to go upstream, and that is actually equal to the hours it takes to go downstream. Read the sentence to yourself again if you have to. But if you think about it, that's really what they're saying. I know it's very simplistic, but let's put it in simple terms. Okay, now, sidebar. How do we get that? We learned in middle school that distance equals rate times the time. For our purposes, that distance is in miles. We're just going to go ahead and call rate R, just for now. And then that time is hours. Now, we're going upstream and downstream in some amount of hours. It's in hours. So let's put our basic distance formula in terms of hours. So if we're talking hours, we know that the hours equal the miles over whatever rate it is, whatever rate we're talking about. So now this gives us something to substitute in to our little basic little elementary arrow equation we've got going on here. Okay, so let's do this. We're going to say 2 plus a ratio of 40. I don't want to talk about the rate yet. And then that's going to equal whatever that downstream of 40 miles is. Remember, it's going to be miles over the rate. Okay, so what is the rate? Well, we've got the still water current, but then we've got this rate of the current itself. So we have still waters. Let's think about this. If I'm going upstream, I'm going to go at the rate of the still water plus the miles per hour. I have to add on more miles per hour. It's going to take me longer. So when I'm going upstream, it's going to be a +3. And when I'm going downstream, that's a -3. Okay? X minus 3. Okay? So those two things are essentially equal to each other. And if you go back and read the sentence, that's what they're saying. They're implying a lot. Yes, I know that they are. But if you go back to our DRT that we learned and think about it, that gives you something to substitute. So now we have something usable. And yes, you could spend a lot of time, and I have done it more than once in different ways. I've solved for X. And I already know what the answer is, but let me show you something slick. We have something usable right now to put into our calculator, and we don't have to calculate one thing. If you can build it and it's only got one variable, an X variable, we're golden. So what do? We push math, arrow up, and it says C, numeric solver. Push enter and clear out whatever's in there. And we are going to say 2 plus alpha y equals, and that will highlight number 1. That's our fraction, And so we put 40 over x plus 3. Then you arrow down, clear out whatever's in there, and we need our fraction. And that will be alpha y equals, and push enter again, and 40 over the x minus the 3. Okay? Double check your entries to make sure you're okay. And let's see where it says okay. Push graph, and that should give us something. Now, remember to push it twice. Okay, for some reason you have to push it twice because it's holding on to the last answer for some reason. I forget why it does that. So now what you see is it took those two equations and it puts them equal to 0. It does a solving for us and it gives us a valid solution for x, which is C, 11.36 rounded miles per hour. Okay. All right, let's move on to number 2. From a given location, Karen walks north at a constant speed. At the same time, Ron walks east at a constant speed. After 3 hours, okay, that's important, they are 17 miles apart. If Ron's speed is 1 mile per hour faster than Karen's speed, what is Karen's distance? Okay, let me explain to you what's going on. Obviously, they're going north and east. So they're going to start here. Okay, this is ground zero. We're going to say Karen goes north, right? Well, her distance is speed because it says after 3 hours, okay? So she goes 3 hours times whatever rate that is. So that's, I don't even have to do parentheses. Oops, that's just 3x, okay? So that's just 3 times her rate, okay? So remember, it's distance times time times rate. 3 hours times rate. However, Ron, we're going to call that R. Ron is going to go at 3x plus, wait. Let's read that again. I don't think that's correct. No, it isn't. Let me erase that. Let me talk through that first. He is going, okay, it's going to take 3 hours. However, his rate, it's 3 times his rate. His rate is x plus 1. Remember, it's time times rate, but his rate is adjusted. Okay? Now, they're going to travel. Ron's going this way. Karen is going up this way. That means Ron will stop here. Karen will stop here. Okay, so this length, which is our hypotenuse, is their distance from each other, and that will be 17. Okay, and let's make sure everything is in miles. Doesn't look like anything 1 mile per hour, so we can safely say that we're calculating everything in miles. Okay, so what we need to do at this point is find out the value of x. But be careful. Be careful. I'm going to highlight this. It says, what is Karen's distance? Careful, careful. This whole equation is her distance. So Karen's distance, so her D equals 3 times whatever x is. So when we get our value for x, we need to remember that's times 3. Okay, so let's start setting this up. Okay, so obviously we're working with a right triangle. So that's a Pythagorean theorem. Okay, so we have 3x, in parentheses, the whole thing is squared. And then we have plus, and let's say 3x plus 3, that whole distance is squared, and that will equal 17 squared. Okay? Now, this is a quadratic situation, so we can't use this nice little problem solver. But there are actually a couple things we're going to do. I'm not going to put all this, I'm not going to sit and calculate all of this out. Let's just put it in our calculator and let me show you a little estimating here that we can do. Okay, watch. So let's back out of this. Let's do y equals, clear out what we have, and in parentheses, we're going to say 3x, close our parentheses, square it, plus, and open our parentheses, 3x plus 3, close, and square it. And let's make this equal to 0. What do I mean by that? I'm just going to do, let's subtract 17 squared from both sides, okay? I'm just going to do a quick little adjusting here. That's going to be a minus, and this will be 0, okay? Now, let's put in minus 17 and square it. Okay, let's try to graph that. Okay, well, let's see what we get here. Let's see. Let's use second calculate, and we need number 2. Okay, and it's one a left bound and a right bound. Okay, our left bound, let's say that equals x equals, well, let's just type it in. Let's say it equals 1, 2, 3. Let's enter that, okay? And then our right bound, let's say that equals 4. And let's push enter. And it's telling us that that rounds to be about 3.48. Okay, so what they're telling us is that x is approximately 3.48. Okay, but remember, to get Karen her distance, we need to multiply that times, let's change colors. So to get Karen's distance, B equals 3 times 3.48. Yes, 48. Okay, now let's look at our options. Obviously, 4 is too small. B was trying to trick us to get us to select what X was. So we're down to C and D. So let's go second mode to back out. And let's say 3 times 3.48 and push enter. 10.44, and that would be option D. 10.44 miles. Sorry. Okay, and you notice what I did. Let's go back to the graph real quick. And what I did is I've got something usable where my zeros are. Because remember, your zeros are going to give you your x value. Now we can go to the table, but that's going to be kind of rough. Let's see. We can say 3.5 and go second enter. But it's not, that's going to be a little rough getting a good value. So go back and remember I use second calculate. And we want number 2. Okay, so what it says, okay, what do you want on the left? Well, I don't want, see where my little cursor is? I don't want negative values. I want positive values. And my line goes between 3 and 4. So it's saying left bound. Well, on the left, I have 3. So I say 3, enter. And then it says, well, what do you want? And see how I got this little pink line here? Okay, it's saying, okay, there's that bound. Now I'm going to say 4 on the right bound. So I say 4, enter. And then now I'm between And it's saying, okay, somewhere between 3 and 4, you're guessing that line is going to give you your x value. So I push enter again, and it gives it to me. When y is 0, it gives me some kind of a usable root of 3.48. I rounded, and then I did what the rest of the things that I needed to do. Okay, I hope you understood everything that I did on both of these problems. I recommend pausing, rewinding, and work through these again. Working alone. Laura can mow a lawn in 3 hours. Working alone. Tim can mow the same lawn in 4 hours. If Laura and Tim work together, how many hours can they mow the lawn? Assume that they start at the same time and stop when the entire lawn is mowed. Okay, how I always remember this is that one job over number of hours. Okay, so what does this imply? This implies that for one job, Laura takes, let's look at this. Laura, she takes 3 hours, and Tim, he takes 4. Okay, so that means 1 over 3 for Laura and one job in 4 hours for Tim. And that all equals to one job taking, I don't know, X how many. Okay, so now you could probably see how to solve this. We have a common denominator of 12, and that is 4 over 3. I mean, 4 plus 3 over 12 is equal to 1 over the X. I don't know. And that will give us 7x equals 12. Divide both sides by 7. Then what will that equal? Well, let's put that in the calculator and see. Okay, well, I see 1 and 5 over 7. Right, maybe I'm right, maybe I'm not. Okay, let's say we don't know. And that's 12 over 7, enter. So let's go. Alpha y equals, and we need to use number 4. No, no, no. Number 3. Number 3 gives us our mixed numbers. Let's go 3 and enter. Ah, there it is. Got to enter twice, obviously. Oh, because I had it in decimal. Okay, got it. Okay, and that means that option B is what we needed. Okay, let's go to number 4. Number 4. Two computers are processing the payroll of a company. Working alone, the first computer requires 20 minutes to compute the task. Working with a second computer, the payroll can be processed in 15 minutes. How many minutes would the second computer require if it were working alone? Assume that both computers start processing the payroll at the same time. Okay, let's give ourselves a little bit more room. Okay, we will set this up the same way we did before. We're going to say the first computer can do the one job at 20 minutes, but the second computer does one job in I don't know how many minutes. Together, they can do the one job in 15 minutes. Now, what I'm going to do, what I like to do is solve it the exact same way. Okay. My denominator will be 20x. That means my numerator is x plus 20, all equal to 1 over 15. This means 20x equals 15x plus, and my math should be right, 300. Let's go double check that. Like I've said so many times, when you're taking a test, you get tired. So, yes, we can do a lot in our heads, but always double check it. Yes, 300. Okay. You could work this out. It's not a hard one. So let's go ahead and say minus 15 on both sides, 15x that is, minus 15x on both sides. This means this is a zero pair, so that goes away. So what do we really have? We have 5x equals the 300. Divide both sides by 5. That means x equals 60 minutes. Okay. Now, and that gives us option D. But just for grins, let's put it in the problem solver, just in case. And like I said, if you're taking a test and you're starting to get tired and you're second guessing yourself, but you're like, okay, I know I set this up right because there really isn't any other way to set it up. So let's go ahead and use math, arrow up, and it's that numeric solver. Enter, clear out what I have. And let's say 20x first, and then go to the next box, which is your expression, second expression, clear that out. And we had 15x plus 30. Okay, remember, we have to push the OK or graph twice. So push that, push it again, and it's, oh, look at what I did. I put in 30 instead of 300. Right, well, let's go back. And I did that by going, let's go second mode and go back to math, up, press enter. Okay, there it is. Ooh, I put in 30 instead of 300. Well, there you go. We were shy of zero. Okay, I should have double checked like I usually do. And remember, you've got to push that graph twice, and it is 60 verifying. I just thought we would go through that while we could. Okay, and let's move on. Number 5. The 3 sides of a rectangular fence are being built in a small backyard, as shown in the diagram below. The area to be fenced in is 80 square feet. If the length is 5 feet greater than the width, what is the size of the width in feet to the nearest hundredths? Okay, so we're going to call, just for simplicity's sake, let's call the width x, and the length was going to be 5 more feet. So let's call this x plus 5. Okay, that's what our length is going to equal. Okay, and we are saying that we have area. Well, we know that the area of a rectangle is length times width. Well, we know our area. Our area is 80 feet. Our length, that is going to be x plus 5, and that will be times our x width. This means 80 equals x squared plus 5x. Well, let's turn this into a workable quadratic equal to 0. That means we have x squared plus 5x minus 80 equals 0. Okay, let's put that into our calculator. Well, let's graph it first. We could graph it or we could use the app. Let's do both. Let's say y equals, go over, clear that thing out. Let's say x squared plus 5x and minus 80. Okay, graph it. Let's see if we can do let's try a fit. Okay, if we go over here and kind of look at it, that's 1, 2, 3, 4, 5, 6. 6, not quite 7 for our x value. That's estimating too close for me. Okay, there would be a couple other ways we could do this, but let's use our application. So let's go to number 9. Okay, you saw what I did. I said apps, number 9, and now I've highlighted number 1. push enter. We are still doing a quadratic equation, which means order 2. We do want the real, and we don't change anything else here. We want auto, and we're using real numbers because it's a fence. So we know that it's going to be in real numbers. So next, we need to do that and graph. Now, let's see. We need 1 enter. And then we have a plus. So push plus enter, and then 5 enter. And now we need a minus. Remember, we use subtraction for this. Enter, and then 80 enter. Okay, now solve is the graph button. So let's push that. Now, we do not want the negative 11. We want the positive value, and that will be roughly 6.79, which is option D. Okay, that was better than graphing and kind of guessing. We could go back to graph. Okay, let's go back out and let's do 6 quit. Okay, so graph it again. And what could we do? We could do second calc, and we don't need a particular value. We need number 2, a 0. Okay. So it says on the left bound, let's do 6. So say 6 enter. And then it's going to be on the other side, right? And if you notice, our pink is just before 7. And that's what our answer is saying. So let's say 7, enter, enter again. And as you notice, it gives us the exact same value. So we have two ways. We have more than one way to solve these, okay? All right, let's go to number 6. Okay. In the diagram shown below, triangle ABC is inscribed in the circle with center D. Okay, the area of the circle is 64 pi, and AC, that's a segment, AC is 6 units larger than B. Okay, so this is AC right here. Okay, and what are they saying? They're saying that AB is X units. Let me write this a little better. That's X units. And they're saying that AC is equal to X plus the 6. But we aren't sure what BC is yet. Okay. What is the approximate length of AC? Now remember, that's going to be X plus 6 more. So don't stop at just the X. Okay. To the nearest hundred. So we'll be rounding. All right. Now here's the thing. There are some properties that we should know. First off, when we have a triangle that is inscribed just like this, and we see that the hypotenuse of our triangle is the diameter of the circle, we know for a fact that this is a right triangle, and the right angle is going to be A. It's going to be the point that's on that point A on the circle. Okay. Now, oh, I could do that right angle a little better, couldn't I? Okay, that's much better. So now we know we have a right triangle, but we can also get the values of that diameter because we know that every circle is the area of a circle, the area of a circle. I'm not sure why that's happening. And the area of a circle equals pi r squared. And the triangle, we'll do the triangle in a minute. Let's just do the area of this circle. That is going to be 64 pi equals pi r squared. Well, we have some canceling. Get rid of the pi's. So now we know that we have 64 4 equals r squared. Well, if we square both sides, we know that r equals 8. So we know this is 8 and we know this is 8. So we know the hypotenuse equals 16. Now that really gives us something pretty good to work with. So let's do this. That's well, that'll be x squared. I was going to say a squared plus b squared equals c squared. Well, we could say that x squared is one leg and then square the other leg, which is x plus 6 squared. And then that will all equal 16 squared. Now, I would say, we could work all this out. And as you know, I'm probably not going to do that. No, I don't want to do that. So let's go ahead and put it into our calculator and see if we can't get some good viable value, some reasonable value for our x without doing tons of work on this. So let's graph it just how we did the last one. We had 2 ways. Let's go ahead and graph and see what we can do. And I do believe that that's exactly what I did. Actually, there were a couple ways I did this, but let's go ahead and graph that. So let's clear this out. Let's say x squared plus open parentheses x plus 6 close, plus the 6 close the parentheses, square the whole thing, and minus, remember, because we needed to put it equal to 0. So we have to say minus 16 squared. Okay. Now that is a kind of a strange looking quadratic, but nonetheless, it actually would simplify into a quadratic. However, let's see if we can graph it. Ooh, there's something viable there, right there. See that? We can play with it a little. Let's not try fit, let's try 6. That's not much better. I don't think we're going to get that is actually better. Let's think about this. We do not want the negative value. We prefer to have the positive value. So let's say second trace, and we want the 0. We want that value crossing the x-axis. So let's say number 2. And let's see, we've got 1, 2, 3, 4, 5, 6, 7. Somewhere, let's say from 7 to 9, maybe. Let's just say 7, because it did say they do the left, then the right, and on the right, let's guesstimate at, let's just do 9. And then let's push enter again. And lo and behold, it gives us a reasonable answer. It says x equals 7 rounded to 91. But we're not done. Remember what I said? Don't let it fool you. That's just an estimated value of x. X equals 7.91. I highlighted what the question was. They said, what is AC? Well, that's going to be plus, here, let me write that out. Let's say that segment AC equals 6 plus 7.91. Okay, obviously that is going to equal 13.91. Okay, all right. And that is the last question in this video. Thank you so much for watching and putting up with me, as well as liking us, sharing us, and subscribing. It is greatly appreciated. Happy testing, everyone.